The second video for section 6 is going to go through lots of examples using all the different derivative rules we've learned so far. The first example, called example 3 here, take the derivative of x squared plus 1 times the square root of 2x minus 3. And again, any of these rules are applicable here. I'm going to start out in this case just by rewriting the original function. So this is x squared plus 1 times, and now I'm going to say 2x minus 3, all being raised to the 1/2 power. And the reason I keep doing this is it's much easier to think of roots as a power, because then we can use our power rule. Okay, we are multiplying two chunks together, so for this one I'm going to start out by using the product rule. Product rule says, first of all, let's write down finding k prime of x. It says product rule says 1d2 plus 2d1. So first function is x squared plus 1, and then the derivative of the second, here's my second function, and notice that I have a function being raised to a power. It's almost like this is an outside function and here's the inside function. We have to use the chain rule. Okay, so the chain rule would say bring the 1/2, the power down to the front, put a times symbol in there, and then we're going to keep the original base the same, that inside function the same. The power goes down by 1, so we're going to have a negative 1/2 there. And then multiplied by the derivative of the inside function. The derivative of 2x minus 3 is just 2. So that was the 1d2 part. Now we have 2 plus 2, so we have 2x minus 3 to the 1/2 power. And then the derivative of the first is just 2x. Now, could we go through and try to simplify some of this? Sure, we could. I don't know if that's the point I'm trying to make from this. I want you to make sure you know where all these parts are coming from, and then we can always pull this up and talk about how we might simplify some of the algebra. So for right now, I have a lot of unused space. I probably should have planned that a little bit better, but that's going to be the answer that we will take right now. Example 4. Find the derivative if function g is t minus 2 divided by 2t plus 1, all of that raised to the 9th power. So when I look at this, we're going to be using a power rule because we have a power of 9 right here. At some point we'll be using the quotient rule. Basically what I want you to see is that we have an outside function, something raised to the 9th power, and then this is all the inside function. A quotient is the inside function. Okay, so dg over dt would equal the following. We're going to bring the power of 9 down to the front. We're going to leave the original base the same, so t minus 2 over 2t plus 1. That's now going to be raised to the 8th power. So we just did the derivative of the outside function, leaving the inside function alone. We're using the chain rule here. And now the chain rule says, now to that, multiply by the derivative of the inside function. All of this is the inside function, so we need to use the quotient rule to finish it out. It's going to look a little messy here. Remember, the quotient rule is low d high minus high d low over square of the low, away we go. So low be 2t plus 1. High, the derivative of t minus 2 is just a 1, so I'm just going to write that down just so we can see that that goes there. Minus high, so t minus 2, times the derivative of the low, 2t plus 1, that derivative would be the number 2. And then we're going to put that over the low squared, so 2t plus 1 being squared. And now we've kind of finished the first way of writing it. We could write a lot more about what that's going to simplify to. We're not going to take the time to do that right now. This one would take a long time to simplify, so I think we'll just leave it like that. Okay, the next few examples are very typical of an AP type question, where you don't really know what the function is. They're just going to give it to you in symbols, but they're going to tell you lots of things about those functions at certain points. So we're going to take a little bit of time to explain this to you. Our goal for each one is to find what f prime at 5 is. So I'm always going to start out by writing, here's what f prime of 5 is, and every time you see an x in the original, I'm going to be putting 5s there instead. 5 is our x value that we're interested in. Okay, so we have function g times function h. That means that we are using our product rule. That's what function f equals. So to start off, I would say that I have 1d2 plus 2d1. So function 1 would be function g, and I'm interested in the x value of 5, times the derivative of h at 5, plus 2d1, so function h at 5 times the derivative of g at 5. Just kind of pause and make sure that makes sense a second. And then if we go into our list of stuff up here, they're telling us what a lot of these things are. G of 5 right here is negative 3. So we're going to have a negative 3 times h prime of 5 is negative 2. H of 5 is 3. And g prime of 5 is 6. So we go through that, we get 6 plus 18, or an answer of 24. Okay, that one is done. Next one, function f equals g of h of x. So in this case we have a composite, we're going to be using the chain rule. So f prime of 5, the outside function is g, so I need to take the derivative of g, leave the inside function alone, and our x value that we're interested in is 5, excuse me. And then we are also needing to multiply by the derivative of the inside function. So we need to multiply by the derivative of h, and again the x value we're interested in is 5. So as we go through and we figure all this out, I know that h of 5 from my info above is 3, and I know that h prime of 5 is negative 2. And so for this one, I need to be able to look up what g prime of 3 is, and it does not tell me that anywhere up here. So this is one that we can't fully answer because we need to know this, and we don't know it. Moving on. Example 3, f of x equals g divided by h. So here we're going to be using the quotient rule. So f prime at 5 would now equal, remember that's low d high, so h of x times g prime of x minus high g of x d low, that's a time symbol there, so h prime of x over the low squared and I just realized that what I've been doing before, I've had 5s where all the x's are. My bad. And so we go ahead and we plug in all the stuff that we're trying to find. H of 5 is 3. G prime of 5 is 6. Minus. G of 5 is negative 3. And H prime of 5 is negative 2. And all of that will be over H of 5, which is 3, and that's going to be squared. So this one we can simplify a little bit. We get 18 in the end. The second part there would be minus 6 divided by 9. And in the end we get, let's see, 12 ninths or 4/3. Perfect. And our last example, now we're looking at g of x being cubed, and just a notation thing, a lot of times you might see that written this way, just like cosine squared of x or sine cubed, things like that. So we have a function inside the cubed function. We need to use our chain rule for this. So f prime of 5 would equal, Chain rule says bring the 3 down to the front, keep the original base the same. So we're going to have G of 5 yet. And that's going to be raised to a power now, not cubed, but now it's going to be squared. And then within that we need to multiply by the derivative of the inside function. So the derivative of G at 5. Okay, so we go ahead and we fill in some of this info. We're going to have 3 times G of 5 is a negative 3 being squared. G prime of 5 is 6. And so we'd have 3 times a 9 times a 6. Challenge yourself. Can you do that without a calculator? In the end, your answer is 162. Bada bing, bada boom. That is the chain rule.